Hello. When last we met, I talked about how IV therapy is delivered in either drops per minute or milliliters per hour. Drops per minute is when you go over gravity or use a dollar flow. And milliliters per hour is when you use an infusion pump. And in your questions, it's going to say if it's a drop factor where it wants you to answer drops per minute, or if it says infusion pump, then you know it's going to want you to answer the question in milliliters per hour. So let's look at our first formula. I use formulas, not dimensional analysis or proportions, because I just didn't learn math that way. I left videos in dimensional analysis and proportions. Please look back at those, as this video is only going to show you in formulas. Okay, so let's set up our first problem when we're looking for drops per minute. So it is volume over time in minutes, okay? And C is our drop factor calibration. And this is going to give us our drops per minute. So that is your formula. Volume over time in minutes times our calibrated drop factor will give us our drops per minute. Okay, so let's look at one of the problems. The first one, we're going to say normal saline, 1,000 milliliters. It's infusing at 120 milliliters per hour with a drop factor of 15. So our drop factor will be 15 drops per minute. Okay, so let's set up this formula. Let's set up this problem. We have what we need to put in the volume, 120 milliliters. Our time in minutes, we have 1 hour, so it's 60 minutes. Times our drop factor, which we have, which is 15. When we plug this in, our calculator, we're going to get 20.8. Okay, we can't sit there and watch the drop factor when you're watching it in decimals, so we need to round. Using your rounding knowledge, this would turn to 21 drops per minute. Okay, everybody see that? If it's less than 5, it would have stayed 20, but since it's greater than 5, after the decimal, it turns to 21 drops per minute. You're going to be rounding to the nearest whole number. So if you had enough time to write that down, we'll move on to another question. I'll keep the formula up at the top. And let's do another problem. We have D5W, 500 milliliters, infusing at 120 milliliters an hour with a drop factor of 10. So using our formula, we're going to plug it in. We have 120 milliliters in an hour, so 60 times our drop factor, which is 10. If we plug that into our formula, we have 20 drops per minute. So our answer is 20 drops per minute. We can take this same problem, and if it had 15 drops per minute instead of 20, all we would do is 120 divided by 60 times 15. And we're left with 30 drops per minute. So again, you have to look at the drop factor, because it can be the same milliliters per hour and your drop factor has just changed. And it went from 20 drops to 30 drops, okay? So that's that problem. Let's look at one more. We have normal saline, 150 milliliter bolus, IV, and it's over 45 minutes with a drop factor of 15. Okay, so normal saline at 150 milliliters bolus, so this is a bolus, IV, over 45 minutes with a drop factor of 15. So we're going to work it the same way. We're going to put in our information. We have 150 milliliters. Our time in minutes is 45. And our drop factor is 15. Okay, if we work that problem out the same way, we're left with 50 drops per minute. 50 drops per minute. Again, we're just plugging in the information that we have into the formula method. Okay? All right, we talked about the shortcuts on the WebEx, so I do want to go over that for those real quickly. We had the drop factor. Also in our dosage calculation book, it gave us the drop factor, and what they call it is the drop factor constant. And so, with the drop factor constant, 10 drops per milliliter equals 6. 15 drops per milliliter equals 4. 20 drops per milliliter equals 3. And 60 drops per milliliter is always going to give us 1. And how they came up with this is basically all they did was put 60 over 10, 15 over 60, 60 over 15, 60 over 20, and 60 over 60, which gave us 1, 3, 4, and 6. But this is something that you can memorize, so that way you can do the shortcut method. Okay, the shortcut method only works when the time is greater than 60. If your problem says 30 minutes or 90 minutes, however, it will not work. If it has 45 minutes, it will not work. You need a whole 60 minutes or more in order to be able to use the constant method. If you want to do it the long way, by all means, go ahead and do it the long way. I'm going to just show you one problem using it so that you can see the difference, okay? So our first problem, we had normal saline 1,000 milliliters. It was infusing at 125 milliliters per hour, okay? And our constant was 10. With a drop factor of 10 drops per minute. If we use the shortcut method, we know that 10 drops per minute is 6. This equals 6 because I just showed you. So all we have to do is plug that into our formula. 125 over 60 times 6. Oh, I'm sorry. 125 divided by 6. And when you plug that in, you should have gotten 20.8. Again, that was our first question, which leads us with 21 drops per milliliter when we round up. So the shortcut, you just take the 125 and divide it by 60. You leave out that extra step, which is here. Volume over time in minutes times constant. Because it's already, the shortcut method already knows that it's going to be in 60 minutes. Okay? If it had 1 hour, we know 1 hour is 60 minutes. So you just divide 125 by the constant, and the constant is 6. You look on page 499 of your calculations book. It gives you the constant drop factor and led us with 125. Okay? Let's look at another problem. D5W, 500 milliliters. Okay? It's infusing at 120 milliliters per hour with a drop factor of 15 drops per minute. Again, if we looked at our book, if we memorized it, 15 drops per minute, our constant for that is 4. So we plug in our formula. 120 divided by 4 yields us 30 drops per minute. Okay, so you're just taking out an extra step with the shortcut. You want to use it, you can. If you don't, you don't have to. Again, remember, this must be equal to at least 60 minutes. You cannot work a problem if it's less than that. So, class, would I be able to use the shortcut method for a problem where it has 150 normal saline 150 milliliter bolus, okay, to infuse over 45 minutes with a drop factor of 10? No, I wouldn't, because it's 45 minutes, okay? So I would not be able to use the shortcut. Again, you use it if you want. If you do not feel comfortable, then go ahead and do it the long way. Okay? Now we're going to be moving to calculating IV flow rate, milliliters per hour. That is when you're going to have an infusion pump. And in the question is going to say infusion pump or over so many hours. Okay? So let's look at our formula. And it is total milliliters over total hours, which yields milliliters per hour. Total milliliters, total hours yields milliliters per hour. So our first one is D5W IV piggyback or IV. Let's leave it at that. D5 1,000 milliliters IV over 24 hours. Okay? So we just plug this, what we know, in. Total milliliters is 1,000, and it's over 24 hours. We don't have to change anything because it's in hours. So if we add this, do our formula in our calculator, we end up with 41.66. Okay? With milliliters per hour, we need to round to the tenths. So we use the same method. So this 41.67 would be 41.7 milliliters per hour. Okay? 41.7 milliliters per hour is our answer. Okay? Let's look at another question. We have cefotan 1 gram in 100 milliliters of normal saline, IV piggyback, to be infused over 50 minutes. Okay, here's our so what do we need to do? Because our formula set has it in hours. We need to first convert the 50 minutes into hours. And if we do 50 over 60, we get 0.83. Okay? So that's 0.83 hours. So now I can go in and put in my formula. 100 milliliters in 0.83, which is going to yield me 120.5 milliliters per hour. Okay? Again, this is in minutes, and we need to convert it into hours. If you're doing dimensional analysis, then your problem would be a little bit longer because you need to cancel out the minutes. Again, I just converted minutes into hours, 0.83. And then once I figured out the hours, I go back and I plug in my problem to give me 120.5 milliliters per hour. Okay, so milliliters per hour is pretty basic. Again, the most important part is making sure your minutes turn into hours and then just dividing. Okay. All right. So let's do the calculating infusion time. Infusion time and volume. Okay? And the formula for that is easy. It's total volume over milliliters per hour. Total volume times milliliters per hour. Let's look at one of the examples. We have D5W, 1,000 milliliters, IV, and it is to run at 100 milliliters an hour. How long will it last? So let's plug in our equation. Total volume is 100, total volume is 1,000 because that's how much we want to infuse is the total volume. Milliliters an hour is given to us, so we just put it over 100. And that's going to give us, if we plug in our calculators, 1,000 divided by 100 gives us 10. This will last 10 hours. So a 1,000 milliliter bag that's being run at 100 milliliters an hour will last 10 hours. Okay? To check yourself with that, all you have to do is take 10 and multiply it by the milliliters per hour, which is 100. And you should get 1,000, which is what our original volume is asking. Okay? Let's do another one. We have normal saline, 500 milliliters, IV piggyback, to run at 125 milliliters per hour. How long will it last? Will the IV last? Okay? Again, we take what we know. We have 500 milliliters into 125. And what do we get? 4 hours. So this infusion should last 4 hours. If we check ourselves, we do 125 times 4. And it gives us 500. So we know that our answer is correct. Okay? We know our answer is correct. One more. Now we can have, these problems can go in steps, A and B. So let's do it. D5W, 1,200 milliliters, okay, to infuse at 100 milliliters per hour to begin at 1,600. Okay? Question A is, how long will it last? So we plug our formula in. We have 1,200 into milliliters per hour, which is 100. So 1,200 gives us 12 hours. Okay? So how long will it last? Our first answer to A is 12 hours. B is going to ask us what time should infusion end. Now, of course, we know therapy, different people come in and out, baths is done, we might have to stop it for a while, but an estimate of what time when we hang this bag should it end, okay? And what we do, it started at 1,600, we know it's 12 hours, so we start adding, and remember it's in military time. So we add 17, 18, 19, 20, 21, 22, 23, 24, 1, 2, 3, 4. It should end at 0400 because that's 12 hours from 1,600. Just that simple, okay? If I changed it to say this was infusing at, let me change this, 125 milliliters an hour. All we have to do is plug in our formula. Again, we have 1,200 over 125. We plug that into our calculators.